Hey, hi everyone. Good morning.
Good morning.
All right, so today we are going to discuss about a new algorithm, clustering algorithm known as DB-scan. Uh, we did discuss about k-means, we discussed about hierarchical clustering. So you will see how DB-scan is different than those two algorithms. So when we discussed about k-means, we have seen that this k-means is capable of finding out spherical clusters. And hierarchical clustering algorithms is kind of an agglomerative clustering which starts from a granular uh, level till the top level, right? So both the algorithms were different. Now we will see that how this DB scan can help you to address some of the issues. One of the major issues you may face is what if there are certain outliers, right? Outliers is always a problem in the data, be it like supervised learning or unsupervised learning. Uh, in k-means, if there are certain outliers, then, for example, now this is your scatter plot. If there are one or two outliers, these outliers could get mapped to one of the clusters like this. And because of this, only few outliers, these clusters may not make sense to you if you are kind of calculating a centroid or you are calculating the average values on of multiple features which you have considered. Even in the hierarchical clustering, if there are outliers at a granular level, if there are certain data points, then even that particular data point may get mapped with one or the other cluster. Now, this DB scan is kind of more this is not prone to outliers, right? So this algorithm will automatically will deal with the outliers and it will discard those outliers to come up with a very unique clusters. And another advantage of this DB scan is that it can also identify different arbitrarily shaped clusters, um, not only just the spherical clusters, but some other shaped clusters also from the data. So, just to, yeah, so basically, this DB scan is known as density based spatial clustering of applications with noise. So, basically, this is an acronym, it has such a long name. So it is a density based. So what it does is in your data, it will see which all observations are closely placed, and wherever there is a high density of the observations in the n-dimensional space, it will cluster those observations. It will not consider any shape of those clusters. It could be of any shape. It will able to identify. So for example, if the observations are something like this, so it will form a cluster like this. Okay, if the it can also form the cluster like this. Okay, so it can come up with any shape, not only just spherical, which was unlike k-means, where the k-means can only find out the spherical cluster, which is in the form of circle. And here this part is important. It will also deal with noise. So automatically, if there are some outliers in the data, those will be uh, not considered and will be discarded during this clustering process. Okay, now let's understand. So here, if you see, these are like spherical clusters, right, which can be grouped in the form of spheres, right? But here, if you see, if you run a k-means algorithm on this, then it will group all these points into one single cluster. Okay, and it will form a cluster like this in the form of spherical. But if you look at the density of these observations, it looks like that this particular outer boundary has a different it forms one single cluster, and these 4 points inside could be on another cluster. So in k-means, you cannot have a cluster inside a cluster. That that's something, it will not able to detect those kind of clusters. It will only detect the clusters like this, which are distinct and uh, which are far from each other. So so this is how the k-means would work, and this is how your DB scan would work. Look at this. This is the basically these are the concentric circles which it has identified. So this outer sphere is one cluster, and the inside this circle, these four dots, red dots, this is another cluster. So it has identified one, two, and three clusters like this. So this is DB scan. It is a highly complex and advanced clustering algorithm. In case in your data, if you find there are certain outliers which needs to be kind of discarded, which needs to be managed by an algorithm, then better you go with a density-based cluster. Okay, and this is how the k-means assign all the points to a cluster, even if they don't belong in any. So these are the outliers, right? If this is not considered, then it will detect this as a cluster. But because of this outlier, it has considered this into this particular cluster, and now the cluster looks like this, right? And here also it looks like this. These are the two outliers. But when it comes to density-based clustering DB scan, so these outliers have been discarded and not considered in any of these clusters. And another major advantage of this density-based clustering is you need not to define the number of clusters. It will automatically detect based on the density that how many dense clusters can be formed in the data. Okay, so it locates a region of high density and separates the outlier. This points something you need to remember when anybody asks about density. If you talk about these 2 points, then I think you are good then in that case. So these are the major two features of this DB scan. It locates, it creates a cluster by locating the regions of high density, and it also separates the outliers. Okay, so but how does it work? So it works based on the two parameters. One is the radius. It for every point, it will consider certain radius, so which you can configure. And in that particular radius, it will check how many observations are falling. If inside that radius, if the observations are falling, then it will include those observations inside that cluster. Otherwise, it will not. Okay, and it will iterate for every observations next to this data point. Okay, so it will pick up one data point and it will find out the it will consider that radius and it will see which all observations are falling inside that radius. And then it will shift to the next nearest neighbor. And again, it will consider the same radius. And again, it will pick up all the points inside that particular radius. So like that, it will keep shifting from one point to another point, and it will find out all the dense uh, regions, around this particular data point, and that's how it will identify the uh, clusters. The second important parameter is minimum number of neighbors. So here you can define how big cluster you want. So for any particular data point, this minimum number of neighbors, it will consider. So as I said, it will iterate from one data point to another data point. So these are the minimum number of neighbors which it will consider, while iteration. So if you say 2, then it will pick up only two nearest neighbors, and then on the two nearest neighbors, it will again consider the same radius, and it will identify which of the observations are falling inside that particular radius. So it will iterate only two times if you mention the minimum number of neighbors as 2. Okay, so these are the two important parameters which you have to use for DB scan. One is the radius and another is the minimum number of neighbors. So see how it works. So step by step, we will understand how it works. So for example, it will pick this particular observation, and this red colored observation is called as core point. So this is my core point, and the minimum number of neighbors I am considering is as 6. Okay. So it will consider this radius of 2 units, and in that particular radius, it will see that how many observations are falling, and that will be mapped to this particular core point. This is the first step. Now, while identifying the neighbors, it will also see that which all points are the border points. So border points, again, there is a complex mathematics around it to identify whether it is these points are falling at the in the uh, on the boundary, or else it is surrounded by other data points. So here this yellow point does not have any other observations on it on this particular side, so it has considered as a border point. So like that, it will keep assigning, considering labeling those observations as the border points or the core points. Okay, now it will shift to this. Okay, so these are all the neighbor points of this particular core point, and in that neighbors, it will assign which of the points are the border points and which can be considered as a core point. Now it will shift to this particular, and this is also a border point because you do not have any other observations beside this. So now this can be considered as a core point because you have uh, observations around it. So now the next core point, it will consider this particular point. So it has considered as a core point. Then again, it will consider the radius of 2 units, and again it will check, which all observations are falling within that particular radius. So like that, it will iterate. So now it has iterated this side. Okay, this is again a core point. All these are the border points. So again, it will shift down. So now this is the border point. Okay, these are all the border points. Now it does not have any other core point, so it will stop. And now this will become one of the clusters, because you must have understood the whole intuition behind it. What it is doing is it is picking up the observations and seeing that which all observations are closely uh, placed with that particular observation. So it is identifying that dense region around it, and then how it is iterating it, it is segregating those neighbors as a border point or as a core point. The core point is a point which is surrounded by the observation, while the border point are the points which are placed at the boundary, okay, which do not have any observations on their on one of their sides. So that's how, based on this, it will identify the dense region, and that's how, it will detect the clusters. Now, see, now let's suppose at one of the iteration, it picked this particular point. Okay. The radius of 2 units, it will create this boundary. And now there is no observations which are falling inside this particular radius. Now, this particular point in this way, it will be considered as an outlier and it will be discarded. It will not be considered in the clustering. Now, this is one of the, uh, it can be also used, this particular algorithm, even to identify the outliers in the data. Okay, because it is an unsupervised learning. And if you have more number of features, and in that more number of features, you need to understand which of the observations are unique or altogether are outliers, or we call it as anomalies, right? So this one single algorithm can be used for multiple purposes, even to detect anomalies and even to identify unique clusters. Okay, so now once this cluster has been identified, it moved to this particular observation, and this observation has been identified as an outlier. Then it moved to this particular. All these are boundary border points. So only one core point is there. So it looked at all the observations around it in within that particular radius, and it has identified that as another cluster. Okay, so like this, it has identified two clusters. So this cluster was a bit difficult to identify because here it has to iterate multiple times, and here there are multiple core points, and around that particular core points, it has identified all the neighbors, and based on that, it has come up with this particular cluster. It was simple as there was no other points which was falling inside this radius, so it has considered as an outlier. And here there was only one core point, so it has just run once and it has identified this particular cluster. So this is the whole uh, process of DB scan. Now, these are the advantages, and DB scan is considered as a state-of-the-art algorithm because of all these reasons, because it can identify the arbitrarily shaped clusters, it is robust to outliers, it does not require any specification of the number of clusters. So now these are the advantages of DB-scan, and these are this will become a disadvantages of the k-means and hierarchical clustering. So during the interview, if somebody asks you what are the advantages and disadvantages of each of these algorithms, then you can mention these points as the advantages of the DB scan and disadvantages of k-means. The one major disadvantage of this DB scan is definitely as it is a sophisticated algorithm and it's a bit complicated in terms of processing um, because it has to iterate multiple times to find out the core points and the border points and all that. So it generally takes a longer time, to run. And the second thing is like uh, so whatever is happening behind this particular algorithm, it's hard to explain, right? You cannot explain. In explanation is also a problem in k-means, but hierarchical clustering can be easily explained because you can have that whole dendrogram and you can see that what is happening at every iteration, right? At a granular level, from the granular level, from the top level, everything is like crystal clear for you. So in the granular items, which all have been grouped in first iteration, and then how they are being grouped in the second iteration, third iteration, and how that hierarchy is being built, everything is like clear. So out of all the three algorithms, agglomerative clustering is much more explainable. Okay, and you can draw a lot of insights out of that dendrogram. Uh, so yeah, so these are the major disadvantage of the DB scan. One is like it takes longer time to run, and the second thing is like it is not explainable, right? So these are the only two major disadvantage of DB scan. Okay, so in terms of understanding, it's simple. Only two major parameters: the radius and the minimum number of neighbors. And based on these two parameters, it can come up with a better clusters. So any questions, guys? And see, and if somebody asks you to do it manually, okay, and you unconsciously you will do like that only. If I give you the data like this, okay, so unconsciously you will select the three clusters. You will put this as an outlier and as a separate cluster, and you will group these observations into one cluster and these two. But how your brain is functioning, how your brain is coming up with these three clusters. So So we unconsciously we will look at the dense region, and wherever there is a dense region, we will consider them as one of the cluster. This is unconsciously our brain works in that way. So based on that, they have come up with this particular algorithm, which also identify the dense region, and based on that, it will come up with these clusters. And you might have seen that some if we have to if something like if I'm giving you uh, if I give you something like this, if I say okay, come up with a cluster. Definitely, you will put these into separate cluster, and all these which are surrounded, which are closer to each other. All these points, you will put that into a separate cluster. This is something, okay, you will do it if you have to do it manually. But if you if you have to explain how you are kind of doing it, you will just say that I will identify, or I have identified all this dense region. All these points are like very closely packed, and they are very dense in this particular region. So I marked it as one cluster. Okay, so that's how we as humans we will do it. The similar thing this DB scan also does, and it identifies. And if somebody asks you what is the process, we cannot able to explain. Just by vision, we identify the dense region. But if you have to programmatically, if you have to build some logic to find out the dense region, so this is that logic, okay, which they have identified. So around the radius, if observations are falling, then it is considered as a dense region if more number of observations are falling. If it is not, then it is not considered as a dense region. Okay. So with this, we will see one example, uh, you know, uh, which I will show you visually, and we will try k-means, we will try hierarchical clustering, and you will see the difference. Okay, how k-means and hierarchical clustering they cannot able to come to identify those arbitrarily shaped clusters, and how the DB scan can able to detect those arbitrarily shaped clusters. So any questions on this, guys? So you might have seen that, okay, these all algorithms are not, in terms of understanding, is not that complicated, okay, but underneath the mathematics is seriously very complex, okay, because uh, first is the mathematics, and second is like programming all those logic in Python is it's a pretty complicated, right? And again, people, the programmers, they have optimized these codes so well that these algorithms will run so fast, and it will process the entire data so quickly. So that's amazing, right? Because currently the data set in the real world is growing so big. Then if you don't optimize these algorithms, programs and all those things, then it may also break. Okay, it may not even scale to that level that larger data sets can be processed on this particular algorithms. So a lot of work these programmers have done in terms of computing, and in terms of processing all this logic so efficiently that you can scale it to larger data sets. And even after doing that, uh, people have felt that these machine learning algorithms cannot scale after a certain limit. Whatever optimization is done on the programming side, but still after a limit, it cannot be scaled. So that's the reason they have come up with altogether different set of algorithms, which we call as a deep learning algorithms. Okay. Now those deep learning algorithms, those frameworks, they have built in such a way that that can be scaled to larger data sets, much larger data sets. Okay, which we will discuss in deep learning section. Okay, so I hope this is clear to everyone. Please confirm.
Clear, sir.
All right. Now let's get into a use case. Okay. So here I couldn't get any real data set which I can show you the graphs and all. So what I have done is I got this a small code to to generate the data. So what here I'm doing is I'm creating a function to to create concentric circles. Okay, a circle inside another circle. Okay, so that kind of a data. So here I'm taking the radius and the number of observations you know uh, in one circle, and then I'm using that function to to create three concentric circles, a circle inside the circle. And then I'm also adding some noise randomly by using this random function. So this is just for the generation of the data. So you can kind of ignore this. Just this is just to uh, build the data so that we can clearly see how this DB scan is better than k-means and hierarchical clustering. And here I'm just using only two columns so that I can visualize the data because I cannot build the chart beyond two variables. Now this is how my scatter plot looks like. Okay, so this is feature one and this is feature two. And if I ask you to come up with a cluster, how you will come up with a cluster? Okay, so you will put this as one cluster. Now these points are quite dense, right? All these observations are closer to each other. There is no white space between these observations. But you see that between this particular circle and this circle, there is a good white space existing. So I cannot map these observation inside, with these observations. So this I can consider as one uh, cluster. This as another cluster and this outer circle as another cluster. And of course, you are seeing that there are a lot of outliers like these points, right? Which is, I'll just reduce the size. Okay, so now you are seeing there's a lot of outliers, right? These all things which are scattered across the corners, and even here inside there are few outliers, right? Which is not even close to this particular circle and this circle. So this is a very complicated data set, and to come up with the clusters by using k-means and hierarchical clustering could not be possible. Okay, let's go and run k-means and see that how k-means is identifying the clusters. Now, let's suppose by looking at this data, I want four clusters, like one for outliers. Okay, I'm just going with a four clusters. So I've defined in k-means four cluster because in k-means, right, we have to specify the number of clusters. I'm assuming that outliers will be grouped in one cluster, and there are three concentric circles which will be identified as a three different clusters. So I'm going with four, and this is how my k-means clustering is giving me the result. Do you think it is good? Uh, this does not look good because what it has done is, you know, it has considered the data points from every region and then mapped it into one single cluster, right? So this has one cluster, this has one cluster. So this is completely wrong, right? And even you will agree, okay? Uh, so one, two, three, four. These are the four cluster which has identified, okay? Uh, and did I initialize this multiple times? No. So here, I just initialized it only once, but you can initialize it more number of times and you can run it multiple times. If you refer to the k-means, we have ran that k-means algorithm 12 times, right, in that use case. So here I'm just running it once. but you can run it multiple times and you can check again, like, how this algorithm is giving you the results. But typically it will give you the result like this, because this k-means algorithm is not capable of finding out the arbitrarily shaped clusters. Now let's get into agglomerative clustering. Here also I'm going with 4, and this is how I'm getting the results. Okay. So again, this does not even make sense, right? So now come to a DB scan. Firstly, I am initializing this DB scan from sklearn.cluster. In cluster module only, we have this particular function of DB scan. And just initializing this DB scan, I'm just fitting it with these 2 columns, okay, of this data frame. That's what I'm doing. Okay, nothing much I'm configuring here. Okay, and this is how my uh, result looks like. Here, if you see that probably when I'm going by default settings, the radius and the minimum number of neighbors could be very high. So that's the reason it is considered as one single cluster as a whole. Okay. So if the radius is big, then it will kind of, consider almost every data points into that. So this is something hit and trial method. Okay. So here you have to there is no thumb rule that okay, this particular value of radius or this particular value of minimum neighbors will give you a better clusters. It is something, it changes from data set to data set. So when I'm going with the default values, it is not giving me any kind of a cluster. Okay, so I have to go and manually have to go and configure the radius. Now how you will do it? So is there any technique by which I can come up with a better R value? Uh, so here, firstly, what I'm doing is I'm using the nearest neighbor technique, and I'm trying to find out what is the average distance between the two neighbors. Okay, and in total data set, how many observations are falling within that particular distance? Okay, so between every pair of observations within the data set, what is the average distance? So that's something I kind of plotted it here. It is data points sorted by distance, and these are like, distance. So it says that from here, okay, so it is kind of becoming constant, okay, at the x values. So generally, it's better you prefer this particular point as your radius. So it is somewhere like 30 or 35. Okay, so here I just considered this radius which is defined as epsilon. Okay, in this particular function EPS. So here I've defined it as 35. So this is one of the technique by which you can identify the radius, okay, through this technique. Otherwise, you can even iterate it with different values like 20, 30. So it will give you an idea within which range, you can try the radius. Now, minimum samples, I'm going with 10. Okay. So now this is how my so it has come up with 3 clusters. So this -1 is considered as an outlier, and 0, 1, 2, these are the 3 unique clusters. And it is giving you the count of the observations inside each of these clusters. Now, when I plotted this particular graph with this labels, so look at this, how it is, how beautifully, it has identified the clusters. So these are the red, the blue, and the green ones are the unique clusters, and all these purple color points are considered as an outliers. So, so that's the beauty of this particular algorithm DB scan. So it has so nicely it has identified these clusters. Though it were like concentric circles, but still it could able to find out those clusters. Uh, This is the only complex part, like to come up with a best epsilon and the nearest neighbor numbers of nearest neighbors. And if you work on this, if you play with this particular parameters, you will see that with small change in epsilon and the small change in the number of data points, you will see a significant change in the clusters. Okay, so the clustering is not a straightforward technique, to solve a problem. You may have to iterate it multiple times. You may have to analyze the data. You have to see that if the clusters are making sense. You have to get it validated by the business. Then only you can take a call that whether these clusters are good or bad. Till then, you have to keep iterating it. You have to, and these are all the different parameters available within these algorithms, which can help you to fine tune your clusters. Okay. So as we have only two features, we can able to view this data. But if there are more number of features, you cannot even visualize whether these clusters are making sense visually or not. Okay, in that case, you have to go and analyze those the way we have analyzed the data previously for hierarchical clustering for the cars data set and for other data set like customer segmentation. So you have to place all the clusters, take the average value for every parameter, and see that how each of these clusters are unique and how they are different from each other. Okay, in what aspect? Make sense, guys? Any questions on this code? So it was quick, right? So easy to understand, but hard to implement in the sense, even it's not, the code is not that complex, but to identify these epsilon values and coming up with a good clusters is something else. That is the tricky part. Okay, so for that also I've shown you one technique here through which you can kind of get an idea what could be the range of epsilon in which you can try, okay, for identifying the better clusters. So I'll take a pause. Let me know anybody has any questions.
So, sir, if we have more features, so we have to go with another method that car and
Yeah, you can take that data set. You can take that data set and you can try DB scan on that. But the only thing is, you cannot able to visualize. I just wanted to show you some through visuals, like how this DB scan is capable of finding out these kind of clusters. So that's the reason, I just took two features so that I can plot the scatter plot. Uh, Otherwise, you can, it can be scaled to multiple features as well. Okay, so you can take all those earlier data set like cars data or the customer data, and then you can try this DB scan on top of it.
okay, I understand.
Okay. Okay. So now, if you have no questions, then we will today discuss on another unsupervised learning algorithm, which is called as recommendation system. Now, this is uh, kind of a generic solution now everyone uses, okay, and we see this particular solution almost on every e-commerce website, on various applications, right? For example, Netflix or Amazon Prime. So you watch videos and automatically there would be a recommendation system. Like, so whatever genre of movies you have watched, and um, the actors in those movies, it will consider all that information, and based on that, it will build a recommendations for you. So let's see how this recommendation works, right? In but when you look at in the e-commerce website, there it consider a different features, right? You buy multiple products, right? You buy you know, um, technology related products, you buy books, you buy apparels. Okay, then it will suggest you the products related to those segments, right? And again, it will also consider the brand and the features of those products and accordingly build the recommendation system. Now, how it works? Firstly, let's understand at a very high level. Now, for example, if it is not a online store, okay, if it is like a brick and mortar store, like if it is a retail store, a person walks in inside a retail store and there is a sales guy, right? How he recommends the products? Again, in the entire store, there could be hundreds of products, right? But uh, how he recommends the right products? Give me a few minutes, guys. Oh, sorry, guys. So let's understand, how does it work? So I was talking about an example, like in the retail store, if somebody walks in, okay, how the sales guys they recommend the products. So first of all, the person specifies what he is looking for, and then accordingly, the sales guy picks up uh, uh, certain products which match his preferences, and then he will recommend that, okay, you can buy this, you can buy that. And some, let's suppose he likes one of the products, so that sales guy he he understands what kind of things or what kind of attributes of the products is interesting that particular guy, then accordingly he'll brings up more other products. It could be color, it could be uh, the shape or the patterns of that particular products, and accordingly he brings up the similar kind of products. So that's how generally a salesperson he tries to recommend the products. But when it comes to online, there you cannot see a person. There you cannot ask the preferences of that person. It's just based on their actions. So based on their past behavior, you need to understand, what could be of his interest. So it is challenging because you cannot interact with the people and you will not able to understand, what exactly they are looking for, right? And the second major advantage of recommender system is that it will drive more sales. You might have seen that sometimes even when you log in onto this kind of websites, possibly you might come up on that particular website to buy some, you might be looking out for some specific product. But when you look at the recommendations, you end up buying more products, right? And generally it happens with me, okay, when sometimes even I'll get surprised, like, okay, this is the product I was thinking about. Okay, good that it has recommended me. And even when you watch movies, without doing much of the search, okay, you will get some good movies recommended for you and you will directly go and watch. And it is often it is happening a lot on Instagram. Now it is an addiction, like Instagram reels and all. My kids, they for an hour, they keep looking at those reels. Now, what is happening is, like, every time you watch one reel, the other reel is looks again interesting because that's of your interest. If it is not of interest, you will not continuously go and watch those reels one after the another, right? Even on the YouTube side. So you will find all the relevant videos which is of your interest, and you one by one, you keep viewing those videos for long hours. So that's how these online platforms, they're driving more traffic, they are driving more sales, and this is how they are generating more revenue. Now let's understand what is the basic uh, mechanism of this recommendation system. So what is this recommender system is, this algorithm, its system capture the pattern of people's behavior and use it to predict what else they may want or like. Okay, it could be books, it could be movies, it could be products, it could be some blogs, articles, it could be anything. You just name it, whatever is there on the online platform, that on top of that, you can have a recommender system. Now, it all started with Netflix. So Netflix was the first company uh, which came up with this recommender system. So if you know about the story of Netflix, firstly, it was just, it used to sell CDs, movie CDs, to for rent, to their customers. And that's how from there, it started, uh, you know, it grew to this online platform. And even the Amazon, if you know about Amazon story, it was like more of a book uh, selling company. Okay, so where people can just look out for the books, and they can buy the books from that particular store. And again, they scale to this level now. So from books, they entered into every segment of the products. So now, you are seeing it in every product segment, be it like books, movies, shoes, or apparels, whatever it is. Now, only thing what you need to understand is what how to to understand the buying pattern of the people. What could be the right attributes of the products you need to consider to give them a better recommendation. When it comes to movies, the genre could be one of the attribute of the, because here the movie is nothing but an item which you would like to recommend to the customers. So genre could be one, the actors could be another, the year it got released could be another, director could be another, right? So there could be multiple attributes you need to identify, which needs to be analyzed in identifying the customer preferences. Okay, even on the uh, LinkedIn also. Okay, so if you go and search for a particular job, then it will understand what kind of job, in which location, what experience levels, which kind of companies you are looking at, and then accordingly it will build the recommendations for you. Okay, job recommendations for you. On the Facebook also. So on every online platform, you will find some or the other way, this recommendation system is being used, and this gives a very personalized experience. Okay, if I am logging with my credentials, I'll find all these products which are getting recommended are very much personalized to me. I am like tech savvy, so if it will recommend all the technology related products to me. Okay, so I'll feel more of like a kind of a very personalized kind of a recommendation getting generated for me. Okay, so if I if I am going on some kind of article based website, again, it will recommend me a very personalized articles for me, which is of my interest, the topics of my interest, right? Like the sports or technology or current affairs. So I need not to spend time in on search. And nowadays, people do not have time, right? If anybody is coming onto your website and if he has to spend a lot of time, in terms of finding out some relevant content or relevant products for for him or her, then definitely they will not prefer those kind of websites. So everyone wants quick thing. So if you have to go to YouTube and you have to search every time after a video, you have to search for a relevant or your kind of videos, then again you will not prefer, because people in just want to read certain things or want to view certain videos or want to buy certain products in their break time, and they want to do it quickly. So now all these players which are onto in the online business, they 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 want to improve that particular experience. So with a minimal steps, how they can help their customers to buy a product, or to get what they are looking for. So how to minimize the steps. So the recommender system is one such solution by which you can minimize those number of steps. Here, the people need not to go and search and need not to go and uh, browse throughout the website, to get their relevant things. So just with the recommendation, it's just like one single click. Okay, if you like that particular product which is being recommended, just click on it, add to the cart, and do your transaction, and your job is done, right? So this is one. And the second thing in the marketing and sales, you might have heard about cross-selling or upselling. So what is cross-selling? For example, again, I'll take the retail store example. Let's suppose if you went to buy a shirt, okay, and let's suppose sales guy has recommended you a nice shirt and you bought that shirt. Now he will also say that, okay, with this shirt, can I show you matching trousers? Okay, trouser will match very well, have some good collection of the trousers. And if that person ended up in making that person convinced, to buy a trouser, then he has made a upsell, because the trousers would be more costlier than the shirt, right? So that is known as upselling. So if somebody is coming to buy a worth of 100 rupees and you ended up you convince him to buy a worth of 1,000 rupees, then it is known as upselling. And in the marketing, people basically train the sales executives, to do more of an upselling, or else they will say that, okay, why you are looking out for this product? It is just 100 rupees, but the quality is bad. Why don't you try with this? Okay, this is, though it is expensive, but it will last for long. So here, again, this is also called as upselling. So cross-selling is like altogether a different category. So the shirt and trouser is also called as a, it also comes under cross-selling, but it is more of a apparel segment. But if somebody is coming for apparels and you also convince him to buy some other segment of products, okay, you just sales guy said, okay, now you bought this, but today we have a new collection on the technology side, okay, of mobile phones, or new collection on something else. Why don't you just go and check? Okay, I'll show you some good products and we will give you some discount and all those things. You might have seen that. All these are like sales tactics, okay, which you might have heard of. So now that is known as cross-selling. So altogether, you moved a customer from one product segment to another product segment. Now, all these things can also happen online, right? So, you might have seen that there's a lot of seasonal discounts or sales, which Amazon, Flipkart, these guys will come up like a big sale and all those things, right? Where they will put all the multiple products on discount. So that is one. Even in the recommender system, you will see that it will also recommend you some other products, which is of, even if you don't search those products, still it will show you some other different popular products, okay, which again entice you to buy. So, and I must tell you that all these applications, online platforms, cannot make business, cannot make high traffic, cannot bring more traffic without this recommender system. So recommender system is very, very important for any online platforms. Okay. So the advantage is broader exposure, possibility of continual usage of purchase of products, provide better experience. These are some limited advantage, but there are many more advantages of recommender systems. Now, if again, now you think about it, okay, as a person, if you have to recommend something, okay, what kind of different ways by which you will recommend? So, one here, technically, there are two types. One is content based. So, if we have to recommend to somebody, we will understand the attributes, as I mentioned, we will understand what kind of attributes or the preferences that particular person will have, related to any particular product. So that is known as content. What is the content of that particular item? So if it is movie, the what is the content? Whether it is an action movie, whether it is a drama, whether it is a fiction, what is the genre of that particular movie? And there could be other content types like uh, the cast and the director, whatever. Okay, uh, the language. So if this person has viewed these two movies, then in all the movies, it will try to find out which all other movies are similar in nature, okay, which this person liked. So now you might have also observed, it's not just about whether the person has viewed that movie or not. It's also important whether that person has liked that movie or not. Okay, you might have watched certain movies which you didn't like at all. If you didn't like that movie and I'm using that particular movie as a reference, and then I'm suggesting a similar movie, possibly that you may also not like those movies also. Okay, so again, it's important to see that how the person has rated that particular movie. Now in every online platform, people started capturing the ratings also. You might have seen that in on Amazon also there is a rating mechanism, in Netflix or in any other uh, uh, movie-based platforms, there are ratings, right? And on YouTube also there's like and dislike and all those things. So now in the recommender system is even getting more is getting better by considering the likes and the ratings information also into consideration while recommending the products. So content based is like, okay, this person watched these movies and he liked those movies, and it will go and find out the similar movies, okay, with respect to the content of that particular movie, and it will recommend those particular products or items to that particular person. While the collaborative filtering, now this is, I'll tell you, where to use content and where to use collaborative filtering. Collaborative filtering is all about for example, now you are with your friends, five different friends, okay, and one friend out of five, three people say that, okay, have you watched this movie or have you read this particular book? Okay, we all liked it. So definitely, if your friends have liked that particular movie or that book, and you are friends because all your there's a lot of similarity between all of you, right? So if three people out of five says that, okay, you should watch that movie, you will definitely go and watch that movie. So it is about finding out the similar people in the entire uh, customer base, and then seeing that how those similar people are what are their preferences, what are they buying, what are they viewing a lot, and then accordingly based on the similar users, the preferences or the recommendations will be built for other users. So for example, I have to recommend to this particular uh, lady. So, and I found that this particular person has a similar preferences as these two other people. Okay, and these two people have watched this movie and this movie and this movie. Okay, and this is the only movie which has not been viewed by this particular person. So it will go and recommend to that particular person. So just like in Amazon, people also like this, right? People who have purchased this particular product has also purchased this particular product. So that kind of recommendation you get, right? And there you can relate. So for example, mobile phone with a screen guard, right? So that is, those are the two products which go together. So there is a different algorithms also known as association rules, which will find out based on the transactions which of the two products are being bought together more number of times. If you go to the supermarket, you will see that there would be a combo, right? People put sugar, oil, 1 kg onions, 1 kg tomato, put that into one, and then they sell it with some discounted price. Because these are the products which have been bought together more number of times. We call it as a market basket analysis. That also sometimes used for recommendation system, but usually that works more on supermarkets and those kind of generic grocery kind of products. But if there are more variety of products, the collaborative filtering works. So based on the gender, based on the age, based on the region, the preferences may change. Okay, and this particular algorithm will try to find out the similar kind of people across the entire customer base, and it will go and analyze their pattern, and then based on that it recommends the right products or the right items to the other users. So here, if you see, tell me what's popular among my neighbors, I also might like this. So uh, this is the concept what is being used in collaborative filtering. In the content based it says that show me more of the same of what I have liked before. So it is more of a personalized in nature, and here it's more of a collaborative in nature. So in personalized in the sense, based on my previous buying pattern, this particular algorithm is recommending me the products. Okay, so that's the major difference between these two algorithms, content-based and collaborative filtering. When it comes to text, Why I'm talking more about this particular algorithm is there are so many different kinds of solutions which you can develop through this recommender system. Recently, we what we did is on our knowledge portal. Okay, so internal there is a knowledge management system, knowledge portal, where people can across the organization they can go and they can read about a lot of different projects which we have implemented. They can read about a lot of materials and all those things. So there usually we use this content based where we had applied the NLP. So NLP, natural language processing, what it does is it identifies the keywords in every document, and that that helps the this recommender system to understand what is the content of that particular document. If one document is talking about machine learning and deep learning, so you will find that particular word keyword appearing more number of times in this particular document. Now it will see that is there any other document where these words are appearing more number of times. So in that way, this is more of a content based, and based on the content, it will go and suggest that particular article or that particular document, to the user. Collaborative filtering could be like a person who has read a certain document on deep learning and machine learning and has also read something on the generative AI. Okay, it's altogether a different topic. There probably the keywords could be different, but here it's more of what others are reading, right? And based on that, it will suggest. So there's a high, instead of sticking to one single content. Here through collaborative filtering, you can suggest some other different contents also or different items also. So there is a wide scope with the collaborative filtering. People might not be aware of certain things. That kind of awareness can also be brought in, with the help of collaborative filtering. So you have to understand in which of the scenarios you want to use which kind of technique or algorithm, to bring that kind of recommendations. Okay, so again, when it comes to implementing, you can have a memory based recommender systems, or you can have model based recommender system. So model based is something like you just train once and then deploy it, and based on that it will predict and it will recommend. So where we use this is, for example, if I have to predict what kind of rating any person may give, a particular product or particular item, and if I have trained that model, okay, I will just go and deploy, and it will go and predict the ratings of that particular of any particular product for a customer, and wherever the predictions are high in terms of rating, it will go and recommend those products. But this model base typically may not work because the behaviors of the customers are changing, preferences are changing. I cannot have one single model which can work better all the time, right? So in that case, it's always better to go with a memory based, where I will consider every time this algorithm will consider the entire data set and it will generate the recommendation on the fly. So it is more dynamic, it is more real time, okay, and it will consider all the recent patterns into consideration, and based on that, it will give the appropriate, recommendations. So here, a lot of different statistical techniques are used, like correlation, cosine similarity, Euclidean distance. Euclidean distance, wherever you will hear the similarity word, there the Euclidean distance will come into picture. Cosine similarity is more of comparing the two text. Okay, so in the NLP, we use cosine similarity to compare the similarity between two text or two documents. Okay, Pearson correlation, right, how it works. So it finds out the relationship between the two numerical data. So if one person is uh, buying pattern, it will consider for another person buying pattern. You consider, and let's suppose you are capturing some numerical column. There you can go and use correlation analysis. So in this recommender system, which we are going to talk collaborative, where we will use the Euclidean distance to find out the similarity. Now let's understand the content based in more detail. Okay, so he's a person, he likes this particular item and this particular item, and internally, this memory based, what it has algorithm, what it has done is it has calculated the similarity score of all the items, okay, between all the items. And it seems that item one, item two, and item three, they are more similar items, right? And if this person has missed out on this item three, then it will recommend this particular item to this guy. It possibly it may not work well on Amazon kind of scenario. So, for example, if I'm buying a mobile phone, if I bought a mobile phone and again it is recommending a mobile phone, it does not make sense, right? Who will buy mobile phone one after the another, right? So their definitely content based recommender system will not work at all. But when it comes to books, when it comes to movies, there the content based recommender system could be a good way of recommending items, right? So you have to understand where exactly these kind of recommender systems would be appropriate. So, for example, look at this. So there is a movie, Batman versus Superman. So as I mentioned, just the content based, you cannot directly use it just based on the content, but even the rating is important to consider whether that person has liked or not liked it. How you will find out by ratings. Now let's suppose this guy has rated 2 to this particular movie, though he has watched this movie and he has rated pretty low. Uh, and this movie has this particular characteristics. It is an adventure and a superhero kind of a movie. And there is a Guardians of the Galaxy. It has multiple genres. It is comedy, adventure, superhero, it's sci-fi. Okay, it's mix of all the genres. And this person has rated pretty high, to this particular movie. Then the Captain America, she has rated high. Now there are other movies also in the library. Okay, and which one to recommend would be something. Okay, we have to solve. Now, how it works is, sorry. So here, this is the whole logic which is used in content-based recommender system. So it will take the ratings of all the movies which this person has watched, and it will. So, there is a rating which we will use as the weights. Okay, and then we have the list of genres. So these are nothing but the content of each of the movie. Whether the content of the movie is related to comedy or adventure or superhero or sci-fi. And there is already the mapping is done. So I'll just put one for that particular genre, and for other genres, I'll mark it as zero. So this is how, I will create a movies matrix, and this is my rating matrix. So I'll multiply these two matrix. It is simple multiplication. Okay, so the weights will be assigned to each of these genres. So as this particular movie has been rated low, so the weights assigned to each of these genres would be low. And for this, as it is having all the genres and rated also very high, so the weights would be high. So this is how, these two input user ratings and the movies matrix will be multiplied, and you will come up with this weighted genre matrix. Now, now we have a user profile. Now, based on this, we will create a user profile. Like how much this particular person likes the comedy, likes the adventure, or superhero, or sci-fi. So So what we will do is we will sum up all these weights so that we will get the overall user profile on the comedy. So she likes comedy, and the weight of that comedy is 18, adventure is 12, superhero is 20, and sci-fi is 10. So, so through this user profile, we can understand that she liked more of a superhero kind of movies, then followed with comedy, followed with adventure and the sci-fi. Now, this is a user profile. Now I'll go and uh, look out for other movies which will match this particular user profile. So what I have done is, now here I will take the proportion out of all the genres. What is the proportion of superhero? What is the proportion of comedy? So I'll take the sum and then divide it by the total. Then this is my overall uh, profile. Okay. So higher is superhero, followed with comedy, then adventure, and then sci-fi. So this is how I'll create the user profile. Now I will use all the movies, okay, list of all the movies which this person hasn't watched, and I will see that which are the candidate movies for recommendations. So these are the three movies, and these are the genres of those particular movie. Now, now I have to take a call, which movie to recommend now. Okay, so now this user profile, the weights will get multiplied with this particular movies matrix which she hasn't watched. Okay, so zero point 0.3, zero point 0.3, 0.2, 0.2, 0.16, 0.16. So this is how it is there. And then I will take the total sum. Okay, this is the sum, 0.66. So whichever movies weights are higher, that particular movie will be recommended. So in this case, this particular movies has a higher weighted weights. Okay, and this is known as recommendation matrix, and wherever for whichever items there would be higher value, it those movies will be recommended. So in this case, the higher value is for this Hitchhiker's Guide of to the Galaxy, and this will be recommended first, followed with the Spider-Man. For the Batman Begins, though it is a superhero movie, but it does not have any other genre into it. It is a simple superhero movie. Probably there is a less chance that that person may like that particular movie. So indirectly, what we are doing is we are predicting the ratings. Okay, predicting the ratings whether that person would like that particular movie or not. Okay, based on the uh, past pattern. Okay, of the movies what she has watched. So this is how, and this applies for any kind of scenario, if it is like product or if it is like items. Uh, you need to identify what kind of attributes you need to look at, and accordingly, based on that, you can build this content-based recommender system, and accordingly, you can generate these kind of recommendations. So I'll take a pause. Let me know if this is clear, content-based. Any questions? Anybody? All right. So I'll stop here, and tomorrow we'll continue on this, and we will discuss more on collaborative filtering, and then we will look at the use case as well. Okay. All right, guys. Then thank you. I'll share the code of DBScan. Um, you go through it. All right, guys. Then thank you. Have a nice weekend. Take care. Bye bye.